All right, ladies and gentlemen, let's take a moment to talk about function notation. Let's take a look at this example problem, or actually this is going to be one of the problems you're working on in class. So we have this equation, f of x equals 4x squared minus 5x plus 2. This happens to be quadratic because one of the variables x is squared. So our function notation says that our output, which normally we would write as y, is f of x. The output is f of x. The function is 4x squared minus 5x plus 2. Now let's take problem B, where we're going to take f of 4. So the problem says to take f of negative 4. It does say negative 4. Negative 4, negative 4. And we need to evaluate this. So what does this mean exactly? So if you take a look here, it says this is normally x, f of x, the function of x. But here we have the function of negative 4. X is always our input, so this negative 4 needs to be our input. So what we can do is we can substitute every x that we see here in the equation for negative 4. So we could rewrite this and say 4 parentheses 4 times negative 4 squared minus 5 times negative 4 plus 2. Let me move my paper out of the way so we can continue working. And now we're just going to use PEMDAS to simplify this to determine the output. Negative 4 is our input, so we need to determine the output when our input or our domain value is negative 4. So we can do that. Negative 4 times negative 4 is 16, so we have 4 times 16 minus negative 5 times negative 4 is going to be positive 20. We have plus 2. Now we have 4 times 16 added to 20 added to 2. And we know that we need to multiply or divide before we add. So let's simplify this. 4 times 16. Well, I know that 2 times 16 is 32. And ladies and gentlemen, sometimes I even need a calculator. And when I don't have a calculator, I just write it out by hand. So 2 times 16 plus 16 is 32. So another 32 would be 4 16s. That would be 4 and 6. So this is going to be 64 plus 20 plus 2. 64 plus 20 is 84. 84 plus 2 is 86. So ladies and gentlemen, what we've determined is that when my domain value is negative 4, and I plug that into my function, my output value is 86. When my input is negative 4, and I plug this into the function, my range value is 86. And notice I'm switching vocabulary words there. Input, output, domain value, range value. So if we were to, for example, create a t-chart or a table with my input and my output, I would have negative 4, and the corresponding output value would be 86. Or if I were to graph this on a table, my y value would be negative 4. I'm sorry, my x value would be negative 4. My y value would be 86. So my coordinate pair, my coordinates, would be negative 4, comma 86. Functional notation is a way for us to understand my input and how that relates to the function in order to determine my output. Ladies and gentlemen, I would like for you to complete the problem set that you picked up at the beginning of class, and we'll go over those answers in class together.